Hi, everybody, and welcome back to day 2 of week 16 of the complex math map. Today, we will be working on the second day, or pages 2, 6, 10, and I skipped a page, I guess, and page 14. So these are the similar concepts in all these pages. So this is what we'll be working on today. I'll zoom in and we can get started. All right, so I'm sorry, this part got cut off, but it says sine waves here. So let's study. So theta, where theta belongs to the realm of, or the domain of, real numbers, right? We are going to study the sine wave. So before we get there, let's just open up to our charts and let's get that unit circle out. It's on C16 too. In the middle you have the unit circle, and the reason I'm doing this is because there's also, you will see these kind of like on page 4 of the chart, you will see these kind of waves as well. These are like trigonometric, or the sine functions of sine theta, cos theta, cosecant theta, cos theta, secant theta, tangent theta, and so on. But here you have only like certain specific angles in this bar chart here. So I'm just gonna go back to the unit circle because it's more easier, and they have many more angles represented here. So let's just go here for now and let's start working. So it says study theta and sine theta, sketch sine theta using degrees and radians, right? So they already have this done for you here. So when theta is 0, sine theta is also 0, and when theta is 45, you just have to go up on the curve. So we just go up, we draw a line, okay? And then when theta is when theta is 45, it's square root of 2 over 2, which is somewhere here, slightly lesser than 1. And then sine 90 is 1 over here. Sorry, my pen is acting up. Just doesn't seem to work. Alright, I'm going to just use my pencil for now. And then sine 90 is 1, as we've sketched it. And then sine 135 is square root of 2 over 2, which is the same as 45. So we're going to come back down. And then sine 180, well, yeah, is 0. So we're going to come back down here to 0. And then sine 270 is negative of 1. Oh, sorry. Is it negative of 1? Yes, it is negative of 1. So I'm just going to go all the way down here. And then 360 is 0. So I'm going to go all the way up here. So that's our sine wave, right? This is in degrees. And now we're going to do this in radians. So I guess it's the same thing. They're trying to tell you that the period 360 degrees is measured in radians of 2 pi. And I'm just going to trace this wave just like we did the previous one. And I'm just going to go up, and it's going to end over here. Okay. So now they say, if you look here, it says simplify odd symmetry. Sine negative of negative theta, sine of negative theta equals negative sine theta. So sine of negative 90, or sine of 270 here, right, is negative 1, as we've seen here, right? So we saw that that's negative 1. And so sine of 270 is negative 1, and negative sine of 90 is 1, and negative sine of 90 is also minus 1, okay? It's pretty simple and straightforward, no magic tricks there. Let's move on to unit circle, simplify the lengths. So they've already done the first one for us. They multiplied it by a scale factor, k equals 1. So you have a triangle, you have a 90-degree triangle, this is 45, so this has to be 45 as well. It's a scalene triangle. It's an isosceles triangle. So if you see, they've multiplied 1 times square root of 2 over 2, and they've said it's square root of 2 over 2. And then if your scale factor is 2, you multiply everything else by 2 times square root of 2 over 2, right? So now your 2's and 2's cancel and you get square root of 2, right? Let's move on to the next one. If your scale factor was 6, you would multiply the hypotenuse and everything else by 6 basically. So 6 times square root of 2 over 2, and 2 goes 3 times in 6, so you'd get 3 square root of 2. Okay. All right, now we move on to the quadrant sign for each function. So you see the unit circle is actually divided into 4 quadrants. If you look at this graph here, you will see that there are 4 quadrants. Is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And if you want to know the signs of these quadrants, it's just mentioned right above it, trigonometric ratio signs by quadrant. And so you have 1, 2, 3, 4, and they actually list out the signs for you. So all you have to do is just look at that and, just follow through with it. So if you see in your trigonometric circle, it's always cos theta, comma, sin theta, right? So your first quadrant is has already been done for you. So you see sin theta is plus, cos theta is plus, and so your tan theta obviously is sine over cos, which is plus, right? And move on to quadrant 2. Your sine theta here is also plus, your cos theta is negative, so plus over minus will give you minus, which is why your tan theta is negative. All right, moving on. Quadrant 3, sine theta is negative, cos theta is negative, so your tan theta is positive because, I'm sorry, did I put a plus here? Yep, your cos theta is also negative. So negative over negative will give you, the signs will cancel and they'll give you a positive. All right, moving on to quadrant 4. Your sine theta is negative, your cos theta is positive, and so your tan theta is negative. All right, that was not so hard. And then they've just asked you to trace this, and you can do that by yourself. So trace, write the quadrant sign for each function, which we've already done. All right. Study the unit circle to write the trigonometric ratios. Figures are not drawn to scale. All right. So here, this is our theta in this right angle triangle, right? So the opposite angle to theta is sine theta, and the hypotenuse is 1, right? So this is our hypotenuse. In these are our 2 legs, and the opposite is sine theta, and the adjacent is cos theta. So adjacent theta will be cos theta, and the hypotenuse is 1. So here, this is our right angle triangle. That's our theta. Okay. So the hypotenuse is here. Look at this. If you just like twist it around, you will see that this will be like this, right? And so this will be actually your tan theta, and this will be your secant theta. All right. So the hypotenuse here is, I would say, secant theta because it's the longest, right? And it's also opposite to your right angle. And your adjacent here would be 1. All right, and your opposite theta here, the side opposite to this theta here is tan theta, and the adjacent to this theta would be 1. Okay, moving on. And here is our right angle triangle, and if you move it by 45 degrees, it'll look like that, right? So your hypotenuse here is this long line, the length, the side opposite to your right angle is your hypotenuse, which is cosecant theta, and the opposite to your theta is 1. The adjacent to your theta is this. This is your adjacent angle to your theta, which is cot theta, and the opposite to this is 1. Okay, hope you got that. And I'm just going to check with our answers to make sure I am not making mistakes. Secant tan, cosecant cot, sine cos. Okay, everything else looks good. And so that was fast. We are moving on to page number 6. All right. And now we're going to study the cosine waves. Again, I'm going to take out my unit circle. They have pretty much filled out everything. Again, theta belongs to the domain real numbers. Real numbers are all the numbers, fractions, negative, positive, all the way up to infinity. all the numbers, rational, irrational, except imaginary numbers, real numbers contain everything, right? So all of these angles and infinity and square roots and all fit into real numbers. All right, so for this part, we're going to study simplifying this odd symmetry here. So cosecant, we are studying cosecant waves. And so for the cosecant of negative theta would be negative cosecant theta. So they have taken, if theta was negative 90, which is 270, right? They're asking you what it is. So we already know from here, 270 is negative 1 and 90 is 1. And negative cosecant of 1 is, negative cosecant of 90 is negative 1, right? Remember, cosecant is the inverse of sine. We saw this in our study of day 1. All right, so I'm just gonna look at my graph here. When in doubt, always check the charts to see if what you're doing is right. Okay, so here is my cosecant theta wave. And if you see, look at the wave, they've traced this. So it goes like that, and then it goes like that, right? So that's what we're gonna do. We're gonna start, we've studied it, and so I'm just gonna sketch it. And it goes like that, and this goes like this, right? And so up to 90 degrees is my quadrant 1, 0 to 90 is quadrant 1, so that's 1, Q1. 90 to 180 is my quadrant 2, so that would be Q2. 180 to 270 is Q3, as mentioned here, and 270 to 360 is Q4. Okay, I hope that is easy. All right, again, we're doing the same thing, simplifying the ratios. So 1 times 1 by 2 is 1 by 2. 1 times square root of 3 by 2 is square root of 3 by 2. 2 times 1 by 2, we cancel the 2's, we get 1. The scale factors become 2 now. And 2 times square root of 3 by 2, I'm going to cancel the 2's, and I get a square root of 3. Okay, and then when my scale factor is 20, 20 times 1 by 2 is 10, and 20 times square root of 3 by 10 is 10 square root of 3. And then in the first quadrant Q1, trace and label the 30-degree triangle, label the corresponding coordinates. Okay, let me get my unit circle out again. Okay, this way. This is, sorry to mention, this is page 6. So, all right. So here we have our unit circle, and I'm just going to go over these angles. So this is what they've asked you to trace and label. Excuse me. So that's my 30-degree angle, right? And so I'm going to write 30 degree, I'm copying it all from here, 30 degree pi by 6. Okay, and my cos theta comma sin theta would be square root of 3 by 2 and 1 by 2. Okay, okay, so they pretty much labeled everything else. We have one thing that they have not labeled, which is 210. So if you look at your unit circle, your 210 is 7 pi by 6 and then 210, and then yeah, 210. And so your cos 220, or sorry, cos 210 here is negative square root of 3 over 2 and negative 1 over 2. Okay, so I think we pretty much covered everything else here. Now we're moving on to converting rectangular coordinates x comma y to polar coordinates r comma theta. So for this, if you put your chart 2 on your charts, C16-2, you will see trigonometry in the coordinate plane, and then it says trigonometry allows us to correlate points in the polar plane, which is in terms of radius and theta, with points in the rectangular plane x comma y. So x squared plus y squared equals r squared. which is the Pythagorean theorem is what you're using here. So r equals square root of x squared plus y squared. And your sine theta is y over the radius. Remember, opposite over hypotenuse. Your cos theta is adjacent over hypotenuse, which is x over r. And your tan theta is y over x, which is opposite over adjacent, like we saw yesterday. And so if you want to find just theta from this tan theta, you do a tan inverse of y over x. Tan theta equals m, which is the slope of the terminal side. So we'll come to this. There are more examples on this later, but for now let's just focus on what they're asking of us. So x comma y is your rectangular coordinates, and so you calculate your r, or the hypotenuse, using the formula r equals square root of x squared plus y squared. And so if your x comma y is 3 and 4, then your r becomes square root of x squared, which is 3 squared, plus 4 squared, which is 9, plus 16, which is square root of 25, which becomes then 5, right? Now 3 comma 3, if I have my x is 3 and my y is 3, so then I'm just doing square root of 3 squared plus 3 squared, which is square root of 9 plus 9, right? Which is square root of 18, right? Or you can write the square root of 18 as, I guess you can write it as square root of 9 times 2, right? Does that sound reasonable? So you can write that as 9 square root of 9 times 2, which then you can take the 9 out, square root of 9. So there's no space here, but I'll explain it like this. So square root of 9 comma 2, 9 times 2 is square root of 9 times square root of 2, which is 3 times square root of 2, or 3 square root of 2, right? That's what's given in your answer key. But if I'm assuming if you left it as square root of 18, would not be a sin either. So that's what we've got here. So we have, let me just simplify this and write 3 square root of 2, okay? All right, if you have your coordinates as 4 and 3, you would again get 25, which is 4 squared plus 3 squared, same as above, and then that would be 25, which is 5. Square root of 25, which is 5. Okay, now we have tan inverse of y over x, right? Theta is tan inverse of y over x, which we also saw in our chart here, over here, right? So now tan inverse, if your y was 4, right? Look at this, your y here is 4 and your x is 3, right? So the same thing here, if your y here, your y is 4 and your x is 3. So tan inverse of 4 over 3, they've already given it to you as 53 degrees. So your angle here is, theta is 53. And how do you calculate your r? So you already know that if your coordinates are 3 and 4, if your x and y are 3 and 4, then your r is 5, right? So that's how they got the 5 comma 53. Okay, if your coordinates are 3 and 3, and so if your coordinates are 3 and 3, you'll get tan inverse of 3 over 3, right? So tan inverse of 3 over 3, look at these two numbers, your rectangular coordinates. They are each of the unit length 3, which means if you have a rectangle like this, right? This is 3 and this is also 3, okay? So this means it is a isosceles triangle, which means in an isosceles triangle, the sides, two sides are the same length, or two angles, and because it is a right angle triangle, you have your two angles to be 45 degrees, because the sum of all the angles inside a triangle should add up to 180 degrees. That's the universal rule, right? For any triangle, the sum of all the angles of the three angles of a triangle must add up to 180 degrees. We already know this is a right angle triangle we're talking about, and we know it's an isosceles triangle because the two sides are the same, right? So the two angles are 45 degrees each, because 180 minus this 90 will give you 90, and if you take this 90 and split it between these two angles, they're each 45. So Your tan inverse of 3 over 3 is 45 degrees. Why? Because now if this is your theta, your angle measure is 45 degrees, right? So your r here will be 3 square root of 2, as we've already found out, right? And your angle here would be 45 degrees. All right. So now you have tan inverse of 3 over 4. Okay. So how do we find, so we know right away, right off the bat, that this is 5, right? So let me go to another triangle here. Okay. So now here this is your 90 degrees. And they're saying your tan inverse of 3 over 4 here, right? 3 over 4, which means your opposite is 3. So if this is my theta, my opposite is 3 and my adjacent is 4, and this is 5. Now we already know that the tan inverse of 4 over 3 is 53 degrees, right? So for this angle, we already know that it is 53 degrees. 4 over 3, tan inverse of 4 over 3 is 53, which means, and then you know that this is 90, right? So 90 plus 53 is 143. So then 180 minus, which should be the sum of all the angles in a triangle, minus the 143 we have, is 37 degrees. So that should be this theta. See how I got to that conclusion? So this becomes 37 degrees. We already know the radius is 5 and our angle is 37 degrees. So I would say don't fret if you're not able to figure this out. This is something a little more advanced, and I don't think at this point you need to be worried if you don't get that off the bat. I actually even looked at the answer sheet for this one just to see how they are calculating it. So yeah. All right, let's move on to page number 10, which is our third page. So again, we are studying sine waves. So look at the, now this time they have filled in your waves and they want you to write the sine theta, just looking at the graph or looking at your unit circle, right? So we know sine 0 is 0, okay? And we know that 45 is square root of 2 over 2, 90 is 1, right? 135 is again square root of 2 over 2, 180 is 0, 270, which is the opposite, is negative 1, 360 is again 0. This is page 10, right? So I've pretty much done these. Now let's simplify the odd symmetry. Sine of negative theta equals negative sine theta. Sine of negative 90 is 270 here. Sine of negative 90 is 270, which is negative 1. So negative sine of 90, sine 90 is again 1 here. So that's going to be negative 1. Okay. All right. Moving on. We can speed up through these because we've already done these so many times. All right. So we know that sine theta at 45. So let's look at our unit circle. Sine theta at 45 is square root of 2 by 2. Cos theta or cos 45 is also square root of 2 by 2. So my cos 45 is square root of 2 over 2. My tan will be sine over cos, which is this over this. Both are the same, so they both cancel out and I get 1. My cosecant will be the inverse of this, or the reciprocal of this, which is actually 2 over square root of 2. But they prefer to, in the answer sheet, I think they prefer to write this as, let me see. Oh, I'm sorry. I don't know how we got that here. Hold on. So I guess you can write it as, if you really cancel out Okay, so if you really cancel out the square root of 2 over 2, you see here, you can also write square root of 2 over 2 as square root of 2 over square root of 2 times square root of 2, right? These two are essentially going to give you 2. So I'm going to cancel these two, and you're left with 1 over square root of 2, which is what they've done here. It is 1 over square root of 2. So cos theta would also, I'm assuming it would be 1 over square root of 2, right? So I'm just going to write that here, 1 over square root of 2. And your tan theta now is 1, and your cos theta is, cosecant theta is the reciprocal of your sin theta. So I'm just going to flip this, and that's going to become square root of 2 over 1. You could also flip this and write, if I were to flip this and write 2 over square root of 2, I could still write this 2 as square root of 2 times square root of 2 and cancel one of these out, and I would be left with square root of 2. So it's just the same thing. I just got, like worried that I was doing something wrong, but it's the same thing essentially. All right, my secant is the inverse of my cos. So again, it's square root of 2. My cot is the inverse of tan. Tan is 1. So this has got to be 1. All right, moving on. My cos 90, let's look at our unit circle. Our cos 90 is 0. So I'm going to write that as 0. My tan is going to be sine over cos. Remember, 1 over 0 or any number over 0 will give you infinity, right? My cosecant is the inverse of sine, right? So cosecant is inverse of 1 is 1. Secant is the inverse of 0. So what is the inverse of 0? I've never heard of an inverse of 0. So I'm going to write that as infinity, right? Because the opposite of 0 is infinity. So now I have a cot. My cot is going to be cosecant over secant, which is really weird here. I have a 1 here and I have a secant here, right? My tan is actually infinity, right? So if I inverse this, if I inverse infinity, I'm left with nothing, 0, right? What is the opposite of infinity? Nothing. I guess you could look at it that way too. Very interesting how this turned out. All right, let's go here. We have cos 45, sine 45, square root of 2 over 2, square root of 2 over 2. They pretty much labeled everything. In the second quadrant, Q2, trace and label the 45-degree angle, label the corresponding coordinates. So this is your second quadrant, Q2. I'm going to trace and label my 45-degree angle using my unit chart. This is 45 degrees. And this is going to be, actually my 45 degree here is actually 135, right? So because 90 plus 45 is 135. So look here, your 135 has got 3 pi over 4, and then your angle is 135. So I'm just going to write that here, 3 pi over 4 and 135 degrees. All right, my cos 135 comma sine 135 is square root of 2 over 2, and I'm sorry, it's negative square root of 2 over 2 and square root of 2 over 2. So I'm just going to copy that down. All right, and then you can trace this, and then they've moved on to 225. Again, I'm just going to copy the answer from here. Cos 225 is, it's on your unit circle. It is negative square root of 2 over 2, negative square root of 2 over 2. Okay, and everything else is taken care of. All right, now let's move on. Substitute theta equals 60. Okay, so my sine theta here is sine 60 and my cos theta is cos 60. My hypotenuse is 1. So you know that Pythagorean theorem states that the square of the hypotenuse, 1 squared, equals the square of the other two sides. Cos squared theta plus sine squared theta equals 1. Okay, so cos squared of 60 plus sine squared of 60 equals 1 squared, right? This is a Pythagorean theorem. They're not asking you to calculate anything, they just want you to write this. So 1 squared plus tan squared theta equals, or 60, sorry, equals secant squared 60, right? The next thing is cot squared 60 plus 1 squared equals cosecant squared 60. All right, so I'm just putting degrees on everything. All right, so that concludes page 3 or page 10 of our D2. All right, we are moving on to cosecant waves. Again, you will see these waves on chart 4. They are over here. So if you see cosecant waves are mentioned here, they are inverse of the sine waves, and you can see them traced out here. That's how they look. And so I'm just gonna look at that and look at my range here. My range for cosecant is, so look at this, my range is from -infinity to -1. So -infinity, because I guess this first, let's maybe if we fill out this will make more sense. So let's maybe fill out this first. So as my theta approaches 0, my cosecant theta approaches infinity, right? So what happens over here? As my theta approaches, as it goes closer and closer to 0, I'm going to go further and further away. Okay, so it approaches infinity. As my theta approaches 45, which is somewhere here, my cosecant theta becomes square root of 2, which is slightly more than 1, right? And then as I approach 90, it becomes 1. As I approach 135, it is again square root of 2. And as I approach 180, as my theta approaches 180, we are again heading to infinity. So this is infinity, or approaching infinity, right? As I go towards, so when I go towards positive 180, I'm going towards positive infinity. And as I'm going towards -180, I'm going into negative infinity. But look here, they mentioned it's positive, so I'm going to keep it as positive infinity. All right, 270 over here is my -1, so I'm going to write that there. And as theta approaches 360, right, what's happening to my cosecant wave? It is also approaching infinity, or negative infinity, right? It's going down. So this is the negative side, and that's the positive side. So this is negative infinity. All right, now I think we can fill this out. All right, so my cosecant theta, it goes from -infinity to -1, right? And it also goes from 1 to positive infinity. Okay, all right, cosecant 270 here is -1. Negative cosecant of 90 is -1. All right, moving on. Sine theta is 1, sine 30 is 1 by 2. Where do I get this from? I'm going to circle. I see sine 30 is 1 by 2 here. So 1 by 2. Cos 30 is square root of 3 by 2 here. So they've already written that down for us. And so now my sine over cos, or my tan, is going to be 1 over 2 divided by square root of 3 over 2. And so when we divide one over the other, they flip. So this becomes 1 over 2. For lack of space, I'm just going to erase it. And write 1 over 2 times, let's flip this because we're dividing it. We cancel these out and we are left with 1 over square root of 3. Just going to erase everything and write that so that it's not confusing. So we're left with 1 over square root of 3. Oh wait, did I make a mistake? No, we're right. Okay, 1 over square root of 3. All right, your cosecant theta is going to be the inverse of this, so it's going to be 2 over 1. And our secant theta is going to be the inverse of our cos, so it's going to be 2 over square root of 3. And our cot theta is going to be cosecant over secant, right? So our cot theta, or our cot theta can also be inverse of the tan theta, right? So let's go to our tan theta here is 1 over square root of 3. So I'm going to just flip that and write square root of 3. Okay. So I hope that made sense to everybody. All right, let's move on to 60 degrees now. So look at your line here, the unit circle. Cos 60 is half and sin 60 is square root of 3 by 2. So sin 60 is square root of 3 by 2. Cos 60 is half. Tan is this over this, and when I flip this, I'll get 2 over 1, and my 2's will cancel, and I'm left with square root of 3, right? And then my cosecant is going to be inverse of this, so it's going to be 2 over square root of 3, okay? And my secant is going to be inverse of this, which is going to be 2, right? And my cot is going to be inverse of tan, which is going to be 1 over square root of 3. Now, if you look at the answer guide, it says square root of 3 over 3, right? Yeah, you can do that. It's just like you're not doing anything actually. You're just gonna write, you know, square root of 3. You're multiplying both these by square root of 3 basically, and so one of these will cancel, and you're left with 1 over square root of 3. But then if you don't cancel it, you're just left with square root of 3 over 3, which is what the answer guide states. But you are perfectly right if you leave it as 1 over square root of 3. Okay, so it's just a different way of putting it, but it's the same thing. All right, so now look at your units, your third quadrant. Now they want you to trace the third quadrant, label the 60-degree triangle, and label the corresponding coordinates. So this is my 60-degree theta. So here, if I see what is 180, this is 180, right? So 180 plus 60, right? What is 180 plus 60? 240. So they want to find out what is this at 240. So let's go to our unit circle, and 240 here is 4 pi by 3 and 240, right? Okay, so what is my cos 240? Okay, cos 240 is negative 1 by 2, and sine 240 is negative square root of 3 by 2. All right, cos 300 is, if you look here, cos 300 is 1 by 2, and sine 300 is negative square root of 3 over 2. All right, let's move on to the next one. Sorry. Copy the combined rectangular and polar coordinates. Okay, they just want you to copy, nothing else, nothing fancy, no trick questions going on. We're just going to copy. So this is 4, my radius is 5. If this is 4, then this has to be 3, because 3 squared plus 4 squared is 9 plus 16, square root of which is 5, right? So copying again, not doing anything. My theta is 53.13 degrees. Did I miss out anything else? I think not. All right, so x comma y is 3 comma 4. My tan inverse of y over x is tan inverse of actually 4 over 3, right? Which is 53.13 degrees. From our previous calculations, we know that that is 53. Oh, we know already. Sorry, I'm sorry. We have it right here. Our tan theta is 4 over 3, opposite over adjacent, which is 53.13. All right, r is square root of x squared plus y squared. This is Pythagorean theorem again. Your hypotenuse is the square root of the squares of the adjacent and the opposite sides. And so your r is 3 squared, which is x squared, plus 4 squared, which is y squared, which is 9, plus 16, which is 25, which is 5. Okay, so your r comma theta, your r is 5, your theta is 53.13 degrees. All right, and I think that is our final page before we move on to D3. I hope that was helpful, and I will see you in the next video. Thank you guys.